Okay. Hello, everyone. Thanks for joining us for the next episode of the live stream here, Jetson AI Labs. With me, we have Dana, Jim, and our guest this month is Paul DeCarlo. He is a developer advocate with Microsoft and a professor at the University of Houston, and he specializes in IoT and edge to cloud, and he has a lot of awesome stuff to show us this week. But first, let's go around and introduce Dana and Jim again.
Oh,
hi. I'm Dana Sheahen. I'm a content developer with NVIDIA's Deep Learning Institute. So if you've explored some of the courses, you may have seen me in the videos there.
and I'm Jim from JetsonHacks.com.
Thanks, Jim. Thanks, Dana. And I'm Dusty. I'm from the NVIDIA team, and I'm on the forums a lot, GitHub, and stuff like that. And I'll be moderating the session here, answering questions in the chat. So if you have any questions at any time, just post them in the chat, and we'll bring some up on air here, or I'll respond to them just in the messages as soon as we can. So first, we're going to cover some recent news items before we bring on Paul to talk about all things IoT. So just yesterday, we launched a new Jetson module. It's called the Jetson TX2 NX. It's basically a TX2 in the NX form factor, and it has the same 256 core GPU that you might see on the TX2. It's got 2.5 times the performance of the Nano, and it's meant for production use pretty much because it's just the module. There's no dev kit built around in this. But if you're looking to make like a mass market device using AI, you might be interested in this. It kind of sits in between the Nano and the Xavier NX. And it's priced at $149 in volume. So it's brand new, just came out yesterday, and you guys can check this out. And it's coming out, all the software with it, with Jetpack 4.5.1, which should be out today or last night. And 4.5.1 is pretty much the same as Jetpack 4.5, which we have a webinar out on now that you guys can go check that out. And my colleague Suhas put a really good webinar out on Jetpack 4.5 with demos and all the new features. So that's pretty much the news from my end. Dana, what do you have going on over in your area?
I'd like to announce, I guess, that GTC is coming up. The dates have been announced. The dates are April 16th through 21st. This is the annual, or actually it's twice a year now, but the big one is in the spring, conference for developers at NVIDIA. There are a number of topics, and it is free to register, which gets you into all kinds of sessions, including a number of sessions on Jetson and robotics that you might be interested in. That's what I got.
Awesome. Thanks, Dana. Yeah, GTC, we're really gearing up for that this year, and we hope everyone comes and checks it out. It's totally free to register, as Dana mentioned, and we'll have a bunch of stuff on Jetson there and all the DLI courses that she runs.
That's right.
So,
right.
Yeah,
There's
it'll be
also
great.
some DLI courses that you can add on, which are all-day workshops, which you might want to try. And everything is online, so it's all remote. So instructors are presenting remotely. You can get onto the course and do the notebooks remotely and all of that.
Awesome. Looking forward to it. GTC is always a highlight of the year.
Yep.
Okay, Jim, what's going on new in your neck of the woods?
So over on Jetson Hacks next week, we'll be publishing some more videos and articles. I think the first one is going to be how to run from USB on the Jetson Nano. So that
Good
should be, that should be rather. The code is already up on GitHub on the Jetson Hacks GitHub repository, but this is kind of a walkthrough. And basically, you just copy the contents of your SD card over to your USB drive. And you don't have to go through the host nightmare, as I call it.
Sweet. Yeah. I'll check that out. Yeah. And I have a USB solid state drive that I hook up to my Nano, and I bet that would be pretty fast with it.
Yeah, that's kind of the approved setup. And
Cool.
I'm wearing my Mars Perseverance hat because that's what my neighbors have been working on for the last 10 years. So I live in Pasadena, which is right down the hill from JPL in kind of north of Caltech. So a lot of folks in this neighborhood have been working on that project You may have heard about it here the last week or so.
Yeah.
Yeah, I watched some like really interesting videos about the sky crane landing that thing and all the artificial intelligence that it uses now, not only for the landing, but the navigation. It's able to navigate on its own autonomously on the Martian surface without needing teleoperation, essentially. So it's really incredible what all those folks have done over there.
And I'll share something with you here. So they have an open house every year that you can go kind of look if you can get the ticket. The ticket's hard to get. So as a computer person, you walk in there saying, I'm a computer nerd. You'll never convert me to the dark side of the space nerd. And you're there for like 20 minutes and all of a sudden you're a space nerd. It's the Disneyland for space.
I was already a space nerd, so they don't have to do that. I actually I was one of those nerds that went to space camp, and then I got made fun of at space camp for being too nerdy. So what?
Whoa.
I was shocked.
I can't imagine that, Dusty.
Yeah. All right. So
I think we've got some questions popping up.
We do. We've had some great questions so far. Oh, here's a good one for you, Dana. We'll answer a couple questions before we bring Paul on here. So there's a question about the containers, and Dana, Jim, and I, back around the launch of the Jetson Nano 2 GB last fall, we've done a lot of work on the containers to containerize the JetBot and Dana's DLI course and my Hello AI World tutorial. And there was a good question here about somebody who was wondering if we plan to combine all the containers into one or how they would do that.
Well, I would say we don't have a plan to do that, but you could create your own container. I believe they're all based on the same PyTorch container.
Yeah, they do all use the same base and the L4T PyTorch base, and you can install the Jupyter Labs on top of that. And I'll explain the reason why we don't have one mega container for them all. And the reason is it's a general best practice with Docker containers to keep it as small as possible for just the use that you want it for. Otherwise, people that don't really need that stuff are downloading, multiple gigabytes of extra data. Maybe it's like an edge device or their internet connection isn't that great. So we really do try to keep the containers limited to just their purpose. But since the containers like the JetBot and Hello AI World are all open source, like the Docker files, you can really easily go in there and either base your own container off of them or combine them all, just basically copy and paste all the Docker files all together. And I mean,
yes, you can build the key there is you can build your own container. I mean, there's all sorts of bases that you can start with that are on NGC.
Yeah, it's
whether
just
these or some others.
Copy and paste, and once you start building your own, I understand. Like, I think we've been doing containers like a year now on Jetson. Some folks have been doing it much longer, but myself and Dana have really been looking at this solid for about a year. You quickly become much more oriented to like the Docker file syntax, and now like I just do everything in containers, whereas before I was a little hesitant. So it keeps my system like a lot cleaner, and my builds are all like fully automated now. So that's been really nice. Okay, let's see if there's any up. There's some good comments about all of the teaching stuff that we put out. So yeah, Dana, Jim, and I initially collaborated on the Jetson AI Specialist certification and the Jetson AI Fundamentals course. So we hope to come out with some new material for that at some point. Like I want to add some features to the Hello AI World, make some new videos about that. I've been looking more at like time series networks for analytics and things like that for other signal processing. So hope to come out with some new stuff on there.
I also see a question that maybe you passed by. It says, will this session recording be available? And yes, it will. All of these are available later, correct?
Yeah. Well, and YouTube, once we end the stream, it'll automatically play the recording of them. And I think if you wait a little bit, you'll even see the comment stream that we found last time. Okay. So I know that Paul has a lot of awesome demos to show us and some like really cool IoT projects that he's made. So we are going to bring him on now. Here we go. Let me add him to the stream. Hey, Paul. Thanks for joining us.
Hey, it's a pleasure to be here, Dusty. Glad to be joining Jim and Dana. Also, folks I'm very familiar with, having read your articles and taken your courses prior to this.
Oh, thank you. And just for everybody who's not familiar with Paul's work, he's posted a bunch of awesome GitHubs that use Jetson and the Azure cloud to do like awesome video analytics, which then you can like check on dashboards and things like that. And he's got some really cool projects to show us. And before I forget, Paul was also one of our first Jetson AI ambassadors, which is just essentially like the specialist certificate that we did, but for teachers and educators. In addition to being like a cloud specialist and developer advocate for Microsoft, you are also a professor at the University of Houston. Isn't that correct, Paul?
Correct. Yes. So it's a lot of hats to wear, but if you look at them holistically, they're actually kind of related in terms of what we do. And I think that's actually a good place to start. Where I've been working with, at least recently, in terms of Jetson-based content and how that's kind of helped me with my university course, and then we can maybe even dovetail back into how that's helped me in my advocacy role at Microsoft in terms of building content that we can enable folks out there to build end-to-end edge-to-cloud based solutions based on NVIDIA hardware and Microsoft Azure IoT services. So the first thing I think that's important to talk about here is I want to say back in November, NVIDIA had announced this new Jetson AI course and certification program. And it just really called out to me for a number of reasons. First, of course, the ability to be able to demonstrate with sort of like an official's designation that you actually know what you're doing on NVIDIA hardware. I thought that was very important. And I saw that it goes beyond just that. There's two tracks. There's like an AI specialist, which is kind of the showcase, that you know what you're doing. And then there's this like enhanced version, the Jetson AI Ambassador, which to me had this like hidden challenge in it. So if you come down here and you look at the requirements for each of these, the number one is that for Jetson AI Specialist requires that you complete a very well put together course from Dana. In addition, you have a project-based assessment where you basically like put the rubber to the road and say like, okay, based on what you've learned here, build a project. It's very open-ended. And I like that. It is sort of challenging you to, put into practice. So that was already taken care of. But the hidden challenge here, if you look at what the ambassador program asked for, is number one, a interview with the NVIDIA team. So this is more targeted for folks doing education and training from what I've gathered. And then teaching or training experience at an academic institution, which implies that to achieve this certification, you have some sort of a plan to actually go forth and teach. And I imagine all of you out there, the challenge here with what that might be.
Yeah, and the ambassador, it's also good for folks that are just doing like, you don't have to be a university professor or like a high school teacher, although that's a great fit for it. But also people that are doing like community groups, like they're doing AI meetups, or maybe they run a hacker space or are doing a robotics club, things like that. And there's a lot of other pluses that you get from being an AI ambassador. Like we recently have this grant program for the Nano 2 gigabytes. So let's say you want to teach a lab with like 30 Jetson Nanos, you can apply for a grant for those. And being an ambassador really helps because we know that you've gone through the material and are able to teach it and know the labs.
And you named off some really awesome benefits there. I mean, even just right here, it'll show you like, if you do want to take this on, just as Dusty was saying, really, I mean, I'd say the requirement here is that you have a desire and a platform from with which to instruct others. They'll give you up to $500 for an approved event if it's held, if it's a free event and held primarily for students. And this can help you out with things like food and maybe if you need to buy ancillary, network gear, that sort of thing.
You can get a lot of pizza. You can get a lot of pizza for that. And I hope at some point soon we'll get back to like the in-person meetups because I really miss that kind of stuff.
Well, and you hit on it right there, Dusty. So I've alluded to this. Of course, back in November, I'm reading this and I was being hopeful, especially with all the news about the vaccinations for COVID-19 and all that, thinking, oh, surely my class that starts in January will be back in person and I will be able to resume what I am used to, which my previous incarnations of the course that I teach at University of Houston, we actually use the Jetson Nano devices to showcase how you can build AI models and that sort of thing, deploy them and do real-time video inference and that sort of stuff.
Yeah, I think I see a bunch of boxes back there too. The Nano boxes. They're pretty. Yeah. Oh, cool.
Xavier back here, Xavier and X back downstairs, and as you'll see here, a cluster of devices in the bedroom. So I eat, sleep, and breathe Jetson embedded. So going to the challenge, of course, as this like clock was ticking more closer to eventually having to give this course, I started thinking about how would I teach my class without making any concessions in this COVID-19 100% virtual world that we live in. And the reason, honestly, the biggest reason here, I didn't feel like it would be right to teach a class and have it somehow be impacted by that. Like I know that, you know, a lot of it's like that internal resiliency. I just couldn't let that happen. And so what we did, we actually went forth teaching this class. And there's a number of different aspects to it, which I think we've got a link for this that we can bring up if anyone's curious to read about the class that I do teach at the University of Houston. And you can check that out right there. The big challenge, obviously, here was how do you teach this course in a virtual format, of which one of the huge things that we do is we try to have a hands-on IoT, you know, hardware-based type of lab with interaction. And so to accommodate that this time around, I got this idea. I don't know where it came to me. It was like mid-December. Why don't we build a web interface and a cluster of Jetson devices that we can interact with remotely and really just strip away all of the, I guess, sort of technical types of hurdles. I don't want, you know, people to be SSHing in and seeing a blank terminal or that sort of thing. I want this to be very, very seamless so that it can work for really anybody. And what you see here is essentially what was created there. It is a web interface, a series of clustered devices in a segmented network. So there is some security involved here. Make sure folks can only access other devices and nothing else. But aside from that, you're given an experience that's more or less what you would expect to see if you had a device in front of you. And so what this looks like today, there's a few enhancements here, is I've built this online portal, if you will, with which I can instruct a full series of labs based on interaction with Jetson embedded hardware. And there's really a simple process here. You know, we take in people. In fact, I just ran one of these yesterday with attendees from Mexico, Bangladesh, UAE, Greece, to name a few. There was 18 different countries represented. So not only did we prove that this worked in Houston with students from the University of Houston, we sort of took that win, if you will, or that success and decided, well, let's open it up to the world. And so what I've been doing here is kind of hosting these workshops where, you know, the first thing I need is your name, and then we assign people to a team, and we go through some presentation content that sort of teaches you baseline of running GPU accelerated workloads, specifically one of the things you were hinting at earlier, in a containerized environment. And then what we do is we go into an AIoT lab. Now, what this is based on is actually a course on the Deep Learning Institute. So this getting started with DeepStream for video analytics on Jetson Nano. And this is all going to make sense, like why we chose this course, which, by the way, this is a phenomenal course to take. It actually, what I love about it, if you look at the prerequisites, like requires some knowledge of C, TensorRT is used here as well. It really gets down to the nuts and bolts of what the DeepStream SDK is made out of. And this, if you're not familiar, is an intelligent video analytics pipeline platform that can in my opinion, make it very easy to build up the types of applications that could like take in multiple camera feeds, as you see here, and be applying inferencing in real time. You might have seen a car just drive by that it picked up there. This is all running off of a device that's running a containerized instance of DeepStream. And we sort of use this course as sort of the springboard to teach individuals that these types of applications, which normally are an optimization nightmare. I mean, from everything. How do you grab frames from multiple cameras? How do you apply the inference or do, you know, secondary inference if you're doing cascading models and those sort of things? All of that is taught to you here. In what we found, we can actually teach this in about 3 hours with individuals. And it gets even better because the way that NVIDIA has set up their Deep Learning Institute is that once you've concluded that you have learned this material and actually followed through a full examination, you receive a certificate that sort of denotes that you are now an expert in this field. And so what I've seen in my class, just to give you a quick anecdote there, students who had no idea that these devices existed or that AI was necessarily something in their grasp can go from knowing very little to becoming certified, as you see here, which is just amazing. You get to tell the world, right? But also I followed up with a number of different surveys, which I'd be more than happy to share the full details with if anyone has questions with. But what we find is over 95% of students who attend this type of training, A, want to get their own device so that they can start exploring it further, and B, are signed up for wanting to learn additional ways to interact with these services in the cloud. And that's where I think we'll have a bit of a segue here, but I know I've been talking for a minute here. So if there's any questions on like what we've gone through so far, we could certainly start there with like how this lab works, and then sort of talk about some of the more extended opportunities that we have available here.
I've got a question for you. So what you're doing is you're going through this lab that's on the Jetson Nano, which is basically the smallest way you can do DeepStream. Are students then able to take that knowledge and use DeepStream on other platforms, you know, to build for themselves or other projects that they might want to expand upon, such as the one that you showed? I'm not sure that was actually on a Nano or something else, maybe.
So great question. The project you just saw does run on a Nano. It is not running on a Nano, but it can. And I think the testament here as to, can I lift and shift a workload from a Jetson Nano to maybe the more powerful Jetson Xavier NX, or even this recently launched new TX device, TX NX, if that's correct. Absolutely, and that's actually a testament to DeepStream. So DeepStream, once you've got a workload figured out there, if you bring the SDK over to another embedded device in the Jetson line, so long as you retain that configuration, and there are some things that you can actually do to tweak it to get extra performance on the higher end models, it more or less just works out the box, as we found in our experiences.
So Paul, how many nanos do you have in your cluster there?
This one, I provide 10 devices, and what we try to do is split. Like, I try to do these courses with no more than 30 people, and it's actually not a hardware limitation. It's more of like a some people will have questions and issues and go off on things and that sort of thing. But and I also had thought about putting. I actually have 30 nanos in the house. I thought about putting 30 on there. But there's some things to consider there. That becomes like it's an additional maintenance burden. You start to approach max amperage that you can pull out of a 120 volt circuit in a US power supply. But it does do the job. And what we found is that by having like 3 people allocated to one physical device, there's no degradation in terms of the quality. In fact, I want to say one of the students yesterday, like whoever was the furthest away, I think was in Nepal, was mentioning like, I don't have any issues accessing this device with 2 other users on it. So that screamed to me like, I think we've solved the scalability problem. And just to demonstrate too, like how easy it is to get to a device, what we've done when the site is up and you're able to access one of these devices when they're turned on, you literally just click into the device and it brings you into a live Jupyter notebook that presents to you the Deep Learning Institute course in sort of an interactive format. So what I love about this is it's very hard to mess this up because you actually have all of your code blocks are more or less typed for you. So you can do builds for different DeepStream applications. But then there's additional challenges usually towards the end where we'll actually ask you to modify certain aspects of the program. And as you can see, I'm clicking into here, opening up a text file that's showing a PGI configuration for an inference model. And students and attendees, they can do this, and you can actually have multiple users doing this at once on a device. They can actually open this up and start to interact with that device itself and start to get all of those results and the hands-on experience without having to bring a physical lab. And so the big thing here...
Does each user basically get their own container?
Each user gets a separate instance to a Jupyter Lab instance that's running on the device. So they start a separate session. And then from that allows them to sort of have that isolated ability to sort of work in their own space.
Cool.
Which is really fantastic.
Do you have them used? Are they different logons or something? Different logon IDs? Is that how you do that? Or just every time somebody comes up, they get a different instance?
Right. So as long as they are logging in from a unique area, they will start a unique session. And so they don't clobber over each other's work, which is really nice and ensures that on my side, I don't have to maintain as many devices to support individuals. And at the same time, everyone gets the same non-degraded experience from using these devices in this cluster.
Paul, I have a good question I want to relay to you here from Hakan. He says, Paul, is your course available for everyone, or do you need to be a registered university student?
So after yesterday, when we proved that this works for anyone in any part of the world, I am happy to announce that we would like to invite anyone who's interested to take this course, and I will personally instruct you through this. We're going to go ahead and bring a link up that will allow you to fill out a form. You choose a date that you would like to sign up to maybe take this course. And not only will we teach you, if you do go through the entire thing, you too will have one of these Deep Learning Institute certificates that you can, of course, add to your resume or profile on LinkedIn and that sort of thing. So we're more than happy to open this up, I think, for wider communities. What we do want to do is maybe cap these at 30 attendees per event, but I imagine this is going to be maybe popular. I know I would love this, so maybe I'm overextending this, but we're going to do 3 sessions, and that means we can support up to 90 people. So start filling out the survey that just popped up there, because we'd love to get you registered and meet you in person a month from now to walk through one of these labs.
Oh, that's great, Paul. Thank you. Because it's free. You don't even need a Nano, and Paul's footing the electricity bill, folks. So go and join up.
And so where this kind of comes full circle, you might be wondering here, I alluded to this earlier, you know, the 3 hats, I suppose, that I wear with instructing at the university, being a Jetson ambassador, and also being a Microsoft cloud advocate. At the end of the lab, what we try to turn people onto is this idea that you can actually apply what you've learned here for various different use cases. One of those being the project that I sort of brought up here just a moment ago. Now, I do wish I had something in view to show you that this is running live object detection in real time on 4 simultaneous camera feeds. And we'll actually show you, there we go. We'll actually show you how you can build this to detect not just vehicles, but anything. And in fact, this whole project that I'm alluding to here is actually mentioned here. It's a GitHub project. So we call this, sorry, that's the wrong link. We call this the Intelligent Video Analytics with NVIDIA Jetson and Microsoft Azure project. So this can be found at aka.ms/intelligent video analytics. It is a GitHub repository that, like, after you've gone through and learned DeepStream, we'll show you how to deploy DeepStream as a container, show you all of the methodologies for configuring it, show you how you can develop your own custom modules for detecting whatever you want. In my case, I do people, vehicles, and my dog and my cat. Then show you how you can filter telemetry, because as you might expect, these types of solutions will actually produce quite a bit of telemetry. In fact, like as you're seeing those detections occur, it's happening multiple times in a second, 30 to 60 times a second. We show you how you can filter that out and send only the relevant data to the cloud for then modeling and say services like time series insights or Power BI. So the quick walkthrough, I know I said a lot of things. This is literally an end-to-end solution, and I'll let you jump in, Dusty, but there's more to unpack here.
I was just gonna say, so the first workshop that you're offering is basically just doing everything locally on the Nano, doing all the inferencing stuff with DeepStream, and now in this second phase of your tutorials and labs, now we're getting into like the more edge to cloud systems. You're sending messages from the edge device back to the cloud for further analytics, and as you mentioned, it's like the end-to-end solution. So this is a great example. I've went through this in the past, and it's one of the few true end-to-end guides out there where you can follow it to a T and be fully integrated with a cloud system.
And that's the amazing thing here too that I like is that we can build off of the Deep Learning Institute baseline knowledge, which that's not even fair to say, the deep knowledge that it gives you about DeepStream. It really forms the proper foundation, I think, to build these types of solutions. Because I've for a year now, as an advocate, I've been teaching how to build these types of solutions, and where people, I think, always sort of miss the mark is I'm still not fully grasping DeepStream. So when you start with that, we found that building the rest of the pieces almost sort of falls in place naturally. So I did allude, there's more to unpack here. So not only is this built with all these modules that walk you through all those components, it's supplemented with a full series of videos actually showing us building this repository almost in real time with you. About each module is approximately 1.5 hours to 2 hours long. So it's approximately 8 hours of content here. So you can't get lost here. If you try following along with us, you'll literally see the steps that we took to build this. In fact, the process I did was I would create the GitHub repo, and then the next day, or create the module, the next day I would take this guy, Eric St. Martin, a colleague of mine, and he's completely uninitiated to this, by the way. So he's like, okay, I got my camera and I got my Jetson device. You tell me what to do. You get to watch him get coached to build the solution from nothing in each one of these segments. So like if you're watching this, and I trust me, this COVID situation, we're all in this age of YouTube. Something breaks, you go to YouTube, you figure out how to fix it, right? And there's always that one video where you're like, the part that I needed to see, you didn't show. It's all here in gory detail of literally taking someone who's never used the device before. So you as the viewer, if you're uninitiated as well, you can hopefully identify with Eric as he's building these solutions from the ground up.
That's why these are like 2 hours, right, Paul?
Yeah, that's right. Well, and I think the other thing too, it's a lot of stuff. So like what you're going to learn, you'll learn how to use Azure services like our IoT Hub to build a DeepStream deployment using our Azure IoT Edge. It's a kind of a container orchestrator, if you want to think about it like that, that uses cloud-defined configurations to go to a device. So for example, the device that you just saw, this is its representation in Microsoft Azure. We'll show you how you can register a device securely, give it a configuration, in this case, that consists of the NVIDIA DeepStream SDK, and show how we can then take inference results from that and pipe them back up into the cloud. But not just that. Again, we show you how to use services like Custom Vision AI, which you're seeing here, to be able to take a collection of images and very easily using their service, you can actually tag the items of interest so that you can actually build your own model that detects whatever you'd like it to detect. And going further with that, we even deploy a module alongside it, which you see here, that can allow you to gather samples from your own environment. So literally the cameras you're seeing here, for me to gather the samples, we used an actual model that was built by gathering samples from this service that connects to my cameras inside my house, again, running on the Jetson device, capture those, and then upload them into a custom vision AI service. And this thing's phenomenal. With just the ability to essentially upload images, select an image, and tag a region of interest, you can then begin to start exporting models that are capable of running or with the TensorRT runtime that's actually part of the DeepStream SDK.
So can you show us, Paul, how you like tag a image in that?
Absolutely. It does look like I need to refresh my instance. So that might take a moment here. And I'll show you absolutely how this works. So this is Custom Vision AI, which is a service that falls under Microsoft's Cognitive Services umbrella offering. And so you'll see here, like here's an example. I've got an individual leaving the house in 2 vehicles. And so what I do is find the object of interest, draw the bounding box, label it appropriately. And once you've gathered enough samples, which I found, I get extremely accurate results with about 150 some odd samples, I believe is what it uses for baseline, and then approximately 30 for training. If you look over here on the left, it takes the lowest amount that you have. So if I have 180, it's like does a 150 and 30 split there.
Yeah. I think if your camera
Yeah.
never moves, it really doesn't take all that many images. Because when I started making my own object detectors, I was like, I'm going to need like thousands of these. But it turns out if you're doing like static camera or just detecting not that many things, or the lighting conditions aren't all that different, the environment and backgrounds don't change, you don't actually need all that many images to make it work well. And this tool looks really nice. Like if I'm not wrong, those images hadn't been annotated before, and it kind of already knew. Like it used some other vision algorithm to basically annotate them for you.
It does get smart. So it's funny. You actually
that
only
was
need
my
a
question too. Yeah, are you actually drawing the boxes and labeling them? You mentioned something about that, or is it finding them, some of them, and you're just approving them?
So at first, it doesn't know anything, and you need about 15 baseline images to create your first model. After you do that, you'll notice as you start uploading images, it almost already kind of knows what you're about to draw a box around and label. I would recommend that you do manually check them all. It's not that it'll get things completely wrong, but sometimes you want to like more finely tune the bounding box. And of course, once you've done that, you get into the ability where you can train models. You can do a quick training that'll spit one out usually in a few minutes. You can use the power of the cloud to use 24 hours of compute time in a cluster, and that actually doesn't take 24 hours. It spins it up and then computes the CPU processing that it would need in Azure, but the wall time is much less, like maybe like 30 minutes or so before it gets it. Then you end up with a model here which can be exported to a variety of formats. So for Jetson devices, of course, you can use raw TensorFlow. What I opt for is the Onyx version of the models, which we then convert to TensorRT. But there's also ways to just export these even as a Docker file that you can literally like drop on, believe it or not, a Raspberry Pi. It's not going to get nearly as good performance as you would get on, say, a Jetson device, but all of those become available targets for the model that you build here.
And it seemed like this was hooked up directly to your Jetson too, right, Paul? So you could like upload a picture right from your Jetson into this just by pressing a button without having to like manually do anything.
Correct. What we were looking at earlier, this camera tagging module, as we call it, is doing exactly that. It's running as a container workload. So again, to put this all together, if you look at my configuration, I've got this camera tagging module and the DeepStream SDK. So they're all running on the same device. So when I actually click into this service, which you can see it's running, if you look at the host name, the Jetson Xavier NX port 3000, I can actually capture an image here. I could say test, we'll call this test 1, save it, and then that becomes an image in a selection of various different images that I can then choose to upload either to custom vision or blob storage. And if you choose it for custom vision, it literally shows right back up as one of your training images within your set. So as you said, they are very much married up together. And there's even ways, we don't necessarily go all the way into it, but there's even ways to automate the deployment of newly trained models back down to the device so that DeepStream picks it up.
Yeah, I see a question here from Emmanuel. He said, can you pull the model straight from custom vision into your edge device and do continuous integration, continuous delivery with that?
Yes, there's, and from what I understand, in the latest version of DeepStream, there's now even a built-in support for doing model swaps at runtime. The way that we accomplish it, we do something called a device twin update, which is a feature of Azure IoT Edge. Yes, a device twin update where we update the URL for a specific model. And what it does, it gets smart enough to pull the URL from your generated model, unpacks it, unzips it, etc., runs it through TensorRT to transform it, then restarts DeepStream to pick up the model. So you can actually update it in production, if you will.
Yeah, and as you mentioned, so I think DeepStream 5, it started using what's called the Triton inference server underneath, which is formerly known as the TensorRT inference server. And one cool feature of that is it will like continually monitor your file system to see if that model had updated. And if it does, it reloads it under the covers for you and just automatically updates it. So this is always a really cool feature because a lot of our users, they have these edge devices out there and automatically want to deliver their new models out to them while collecting data from the edge too.
So far we've kind of, I guess, hit the two obvious things, like how do I build a custom solution? How do I build a custom model? We also go into that detail on like, well, now that I have all this data, what do I do with it? And so if we go back to the resource group in Azure that contains like all of my services that sort of make up this solution, which I've aptly named Accelerated Edge. If we come in here, there's a few other interesting things. One of these is Stream Analytics Cloud and Stream Analytics Edge module. Now, this Stream Analytics Edge thing is interesting. It probably doesn't surprise you. Azure has an ability to process telemetry in near real time, live as data is in flight using something called Stream Analytics. But those same services can actually be deployed down to your device if it's instrumented with IoT Edge. And so here you're going to see this query, and it's going to make a little bit more sense. I know I didn't SSH into a device before the show, but let me SSH into this because I think this is really cool and something y'all will definitely want to see in action. Take me just a moment here and explain to you what this is doing. So as I mentioned, the type of telemetry that you get from running inference on a device in real time is, well, it's going to fill the whole screen. I should actually, let's go ahead and increase the font size here so folks can, you don't have to read this. What I'm about to show you is just to prove to you how much data these things produce. So let's go ahead and do a docker logs-f on the NVIDIA DeepStream SDK module. Show you the telemetry this thing is producing. It's welcome to the matrix, right? That's what happens when you're doing inference, 30 times per second. So how do you make sense of that type of data? How do you filter that? As soon as I can control C there, I'll show you how. So we actually have, do a docker ps, show you like what's running here. And you saw this in Azure as well. There is a DeepStream Analytics module that I'm running. What that is, it's Azure Stream Analytics exported to run locally on the device. And what it does, it takes in telemetry from DeepStream and filters it out. Now, I'm not going to say that what my query I came up here is mathematically correct, but this is essentially a debouncing function for detections that come through. So as you might be aware, when you're doing inference, if you include every single inference, because of the way bounding boxes include each other and things like that, you could produce false positives, like thinking that you saw two of something when there was really only one of something. And so what this service lets us do is it lets us write queries against every one of those results as they're coming in real time. and actually aggregate them over time. So I can do things like, aggregate this in every 15 seconds using something called a tumbling window. Tell me the average of what you're seeing and then flatten those results. And so what this does, it allows me to, just like you would have a debounce on a circuit, it allows me to debounce the detections. And so the results that I'm actually pushing to Azure are extremely accurate. I'm not saying that they're 100%, but having done some edge case tests here, they're extremely accurate. And so what this lets me do is now when that data comes from the device, I don't send every DeepStream result. That would kill your bandwidth. What I instead do is every 15 seconds, I send summarized detections that are produced by that flattening function. And so from this, my payload actually like shrinks down enormously to where it's like, number of people, 1 or 2 in that 15-second window, as opposed to every single detection that occurred in the epoch.
So when you say debouncing, is it similar to like tracking and re-identification? So if it's one car going by, you don't need every frame's detection from that.
Yeah, it's hinting at it's very similar like with buttons when you do a button debounce in a circuit where it's like you press the button and those microscopic points where like it's touching and then pulling away actually get registered as like multiple presses. Object detection algorithms do the same thing when they first see an item. So if you're detecting raw results, and let's say you took a naive approach and you were like, let's just take the max of what I see because that's probably accurate. It's not accurate because, again, when something new enters an environment, the way the bounding boxes work, particularly in detection models like YOLO, faster RNN, those will actually produce, usually on initial seeing of things, it'll think it sees 2 of something, like split second. It's so fast you barely ever see it. And this filters those types of results out and also helps if you do have multiple objects occluding so that it doesn't see 1 or 4, it actually averages them out, and usually you get to the right result if you've sampled it over a long enough period of time, which 15 seconds was more than enough. I think 5 seconds will actually do it in my testing. So from here, now that we're getting good results, right? Like this is the thing. So now you're seeing that I'm only sending like every 15 seconds these well-filtered results. I can actually plug those into services in Azure. One of which, if we go back to our resource group, is this thing called Time Series Insights, which is, as you might expect, a time series type of database and visualization service where I can now go in and for each of my cameras, as you saw here, I've got one in the home, pool, street, and yard. I can actually come in here. Let's say I want to see like how many vehicles were in the street. And I can plot that very easily by just adding that into here. And you can see where the detections are that it is seen for that particular item. And this is actually looking at historical data when my brother's car was parked in the driveway. If I was to like squeeze this forward and go into real time, you'll start to see that these numbers start to break when there's actually not a vehicle present. So it's very interesting how this works. Because gives you like that ability to see things over time, but we even take it further because this is a near real-time visualization service. It uses warm queries, which can allow you to essentially look at data in a hot path that it gets the results really quick. But we also do something where we use something called Power BI, where I'm actually getting these results in basically real time and graphing those in a interactive charts. This might be a little bit more exciting depending on what you're trying to do. So again, with those filtered results coming from the Stream Analytics module, we can now do things like, because I've got accurate results, I can do things like say, where's the cat? And we can click here and I can see and tell you that the last time the cat was seen by this system running inference was in the home. And prior to that, the cat was out by the pool, which is accurate. When I let her out earlier this morning.
This dashboard looks really nice, Paul. How did you actually like put this together? Do you have a bunch of SQL queries that are then charted, or does it do it automatically based on the schemas that the IoT module pumps out, or how does it actually work?
So because the way we're pushing the data is pretty flat, it's like, there's a timestamp, there's a object, dog, cat, person, vehicle, and then there's a value, a number with it. It's a pretty flat structure. It imports natively into Power BI. And the other beauty here that you'll see is that because it's a simple structure, building the visualizations, I know someone on the Power BI team is going to say, like, maybe you shouldn't say it's this. Maybe they want me to say this. I'll take that back. Literally, you drag and drop the components and click them until they look the way that you want them to. I want to say I didn't spend much brain power on the dashboard, and that's a testament to how good this product is that if you've got good data, it's nice and flat. There's a number of different visualizations that you can just pick up. In fact, the desktop tool that I authored this in has all of these different visualizations that I can choose. And then from there, you just go ahead and build exactly what you need, given what's there. And there's ability to make custom visualizations and things like that. But honestly, there's not a lot to do here. It's kind of like, it's like in Excel. You drag things until it works right. I'd say this is easier in Excel.
So here you've gone from essentially, because in theory, someone, if they just had a local network they want to do, they could do charting on the Jetson using Matplotlib or Plotly. I've done some like Dash server boards and stuff, but it was all just real local to my network. This, you can access this from anywhere in the world. And I guess if you wanted to scale this, you could just add more Jetsons into this system and say you're like a distributed system and all view them through this one web page.
Totally. And it doesn't just support that. It has obviously governance features in there as well. So if you had aspects or you need to enforce, say, row level security on the type of data that this is making sense of, you can do that. And it even has a feature for live analytics. So you'll see that this is mentioning blank here because no cars are in the driveway or in the street, and maybe we'll get lucky again. But if one drives by, and again, this is again using Power BI, using their live dashboard feature functionality, you can see these object detection results. And I'd say the delay is maybe 5 to 15 seconds latency at the highest. But if we get a detection, in fact, I'm tempted to just go run downstairs and trigger one. If we get one, you would see this dashboard all of a sudden light up. So we show you all of that from the end-to-end perspective. And again, like putting this all together, right? Because I know we've talked about so much here today. We could sort of start with the NVIDIA Jetson AIoT Lab. Get you trained up on DeepStream using the wonderful course that's available on the Deep Learning Institute. Once you've finished that, we point you off to further learning, which would consist of the intelligent video analytics with NVIDIA Jetson and Microsoft Azure project. And at this point, this is where you really separate, like, okay, if you took that training and you decide you want to buy a device and you want to do something with it, this is the training that you would go to next to truly build an end-to-end solution. And what this will leave you with, I promise you, is the knowledge on building, custom DeepStream applications, how to deploy DeepStream as a container using IoT Edge, how to build your own custom object detection models, filtering telemetry with Stream Analytics, and of course, those visualization techniques with time series insights and Power BI, giving you the full end-to-end. And if I can't be there to teach you, the good news is we've got 8 hours of live stream content to help walk you through it.
Can I ask a question? This is really awesome, and it's launching you into, as you said, other applications. Can you tell us maybe some case studies or use cases that you're familiar with that maybe companies or other people have tried or imagined? It seems like the sky is the limit here.
Definitely. I'd say not a week goes by where I don't get reached out either by a customer or partner, even internally at Microsoft, that sees this work and is just usually asking questions. Either they're in process building something in those domains, which include things like smart agriculture, which is really just amazing, something that's near and dear to me. In addition to seeing solutions that are deployed in, like, we've got air-gapped factories that are doing things like quality control where they can see the status of a widget that's getting manufactured, and can tell if there's a defect at various different aspects of the production line. Other things that are cool is seeing this deployed in what I call rugged environments, the most rugged of all, offshore environments, where sometimes you have the internet, depending on if the clouds are out or not. But the big one, the really big one that I would point a lot of folks to, you can find this one at aka.ms/project15, is this project called Project 15, which exists on GitHub and is really a similar concept to what you have seen thus far. And this was built on the concept of every 15 minutes, believe it or not, and this is a sad statistic, an elephant vanishes from this earth, either by means of poaching or natural causes. And what Project 15 does is it actually employs custom vision solutions that are, of course, trained to detect elephants and different statuses of them to be able to provide assistance in conservation and sustainability of the elephant population. So really, forward-thinking type of idea, and as you can see, using AIoT for good, if you will. So definitely would suggest checking this out. You can learn more about it, again, at the link that was proposed there. I know we're hitting end of time, so I want to make sure we have time for maybe a question or two and close out. That's pretty much, I know this was a lot. I think the last thing we maybe want to leave folks with is feel free to join us for that next round of training. We'd love to get you all in. Again, that form, the link for the form, we can bring that up one more time. We'd love to get you in, and we'll open it up for questions and close out.
All right. Thank you so much, Paul. And I will post that banner in the chat again here too, real quick.
And you said the chat will show up later so they can find it again, or does it need to go into comments or something?
I think we found last time that the chat does show up a time. It might not show up right after the stream ends, but if you view it an hour or two later, the chat will show back up when you watch the stream again. So let's dig out some questions. Do you guys have any further questions? We have about 3 minutes left. We can chat here. So there were some good questions about like firewalls and how you deal with those, Paul, and Dana, you might have some experience too. I don't think there's not any firewall that comes pre-installed on the Jetson, but did you have to do anything with firewalls, Paul, when you set up your local cluster there to get access inside the Docker containers and stuff like that?
Yeah, the thing that I do, number one, is the switch is on a whole different segment of my home network. So those devices experience a different route than everything else. So you're not going to be able to see my work machines and those sort of things from them. That's more or less the most important thing. The other thing that I do is I do not leave the lab on unless I'm conducting an actual in-person training. So I do tend to turn it off. I mean, I'd love to keep it on 24/7 so that people could use it whenever. That's just like not a good idea for numerous reasons. But by keeping it on and like sort of knowing who's accessing what and that sort of thing, that allows me to do this in a pretty secure manner. And I mean, you have to take these things with what the benefit is, right? Like, you don't want perfect to be the enemy of great. I would argue in this case, which is, sure, we could do something, where people get an isolated instance and can't see each other. Honestly, I'm just trying to beat the issue that COVID-19 has caused for us all and try to bring back the ability to do these types of environmental learnings together with real hardware. And this is one way to do it. So far, it's so good. I hope I don't regret this for some sort of security reason. I'm sure I won't. But just know the way it's set up, I actually did contact 2 or 3 experts locally to ask them some questions. They say it's good the way it is.
I think that's a positive having in the container, right? Peter asked a good question about what type of teardown do you have in between sessions? I think it's just like restart the container, right?
Well, but for these courses, you might have to read Flash, right? Or you have
No, just restart. So one of the nice things is that the repo for all of this is pulled onto the main image as it's literally a Git repo. So a Git reset on all 10 devices satisfies it.
Gotcha. So before we get off track, I wanted AK had a couple good questions. Thanks, AK. He was wondering what detection model or detection architecture are you using for your object detector?
Underneath the hood, we're transforming a YOLO V2 based Onyx formatted model. So it is using YOLO V2, but it's been converted to Onyx, which then the TensorRT engine picks up and transforms at runtime to adapt to the Maxwell architecture on the Jetson Nano. So YOLO at the end of the day. And I believe Custom Vision, I think, is going to be updating that to a more modern version of YOLO. That is one that they've stuck with because it is kind of like the tried and true, but I've already put in my request. Why not V3 at least?
YOLO's fast and furious these days. It's a lot to keep up with. And AK had another good question. So all the streaming that you've been showing, is that, he was asking, is it JPEGs or is it like RTSP feeds or is it compressed H.264? How does the video streaming aspect of this all work from here?
This is RTSP feeds, and the reason you're seeing this back is then the Jetson can serve back an RTSP feed. So it's an four RTSP feeds muxed into one RTSP feed out. But yes, it is RTSP at the end of the day.
Oh, okay. So this is the RTSP coming from the Jetson, I think, because we saw some detections on that earlier. Cool. Okay, and this is through DeepStream.
Correct.
Okay, maybe we have time for one more question here. There's a lot of people saying thank you, Paul, and they're interested in joining your workshop. So thank you so much. Okay, I think with that we're a little bit past the hour here, so we got to go. Well, everybody say bye to Paul. Thank you, Paul. You were an awesome guest and have
thank
so
you.
much
Thank you,
Paul. That was great.
It's been a pleasure. I'm so happy to be here, and I look forward to seeing some of you in the class. We will see you in a month's time, I'm sure. Take it easy.
Yes, thank you all for joining us.
Yep. Thanks, everybody. We will see you next time. Take care.